Yeah, welcome.
Okay, so the standard form for exact differential is of this form: m as a function of two variables, the x, plus n as a function of x and y, the y, equal to 0. So if this differential equation, if it is exact, okay, exact in the sense that your partial differential of m respect to y is equal to what? Partial differential of n respect to x. I want to note that your attachment to the x is your m. Your attachment to your the y is your n. Okay, so you differentiate your m respect to the other function, to the y. Partial differential of m respect to the other function, y. And then your n also, you differentiate your n partially respect to the other function, there else. So that's that. So if that is an exact, if the equation is exact, then there is a function f. There is a function f as a function of two variables, such that partial differential of f respect to x is equal to m as a function of two variables, and partial differential of f respect to y is equal to n. So we now use either this one or this to generate the general solution. Okay, so how do we use this one to generate the general solution? You can use this one to generate the general solution. You can use this one to generate the general solution. Okay, so if you want to use this one, if you want to use any of them, we take the integral of both sides. Take the integral of this one. Take the integral of this one. That will be f equal to what? Equal to integral of m as functions of two variables. Then either you put del f or you put dx, no problem. But we are doing partial integration in this place. Then plus the arbitrary constant g of y. If this place is del x or dx, your constant will be g of y. If it's del y or dy, your constant will be what? Will be g of x. Okay, so that's not this place. Let's call this one let's asterisk let's give it a name. F is equal to this. This f now will be our general solution, but we need to find the arbitrary constants. G of y is our arbitrary constant. So we need to find the value of that. Okay, so how do we get that constant? How do we get the constant? How do we get that constant? How do you get that constant? Welcome on board. We are looking at exact differential equation. Okay, so what we are going to do from where we stop here, we are going to differentiate this one respect to y. So differentiate partially respect to y, So we're going to have the partial differential of f respect to y equal to del y partial respect to y of your integral function, which is this one. Okay, then plus g of y. So you can open the brackets for the right hand side, and that will be equal to what? This. Okay, and then close the brackets and then plus. If you differentiate this one, that will be g prime of y equal to n as a function of two variables. You can check when we start. So we can check that. So this one is equal to this one. So by the time you get the integral of this one and this one, you realize that this one and this one we almost equal, and something we cancel, something we cancel, and finally you integrate both sides of the equation. You integrate both sides of the equation, and then you get your what? You get your g of y. So once you get your g of y, you come back here and substitute into this equation that I put asterisk there. So that is how to solve exact differential. That's 2xy dx plus s squared minus 1 dy equal to 0. So that's what we have uh, for the first question. That's what we have. So what we are going to do in this case is to correspond this to the standard equation, correspond this to this format, um, correspond this. This is the x, this is the dy equal to 0. So if you do that, you realize that your m is what? Is 2xy. I told you the attachment to your dx is your what? Is your m. And then your n, as a function of the x and y, is the attachment to your dy is your m. Is your n. Is your n. That's s squared minus 1. So what we're going to do now, we need to test the equation if it's exact or not. So how do we do that? We're going to do the partial differential of m respect to the other function. That's respect to y. That's del m del y. So, and this one, this m is a function of two variables. So what you're going to do is that I told us that in partial differentiation, okay, you have two variables, okay, you do it respect to the function, respect to y. Why the other functions, the other variable will be kept as a constant. Will be kept as a constant. So 2x will be kept as a constant. Then you differentiate y, respect y. So that's that. Then go to partial of n respect to the other function, respect to x. Okay, this will be what? 2x. So we can see clearly, obviously, this and this are equal to each other. This is exact. This is exact. Then the next question is at the end of the road? No. Capital no. We need to get the what? The general solution to this differential equation. And how do you do that? Once the equation is exact, it implies that there is a function f as a function of two variables such that variable and also partial of f respect to y is equal to what? Is equal to n. So the choice is has. You can use this one to get the general solution. You can use this one to get the general solution. You need to subscribe. Let's make this section interactive. Subscribe to the channel so that you can be able to type your questions. Okay. Very, very important. And also, the algorithm, we need to push this video to wider audience, to large audience. Okay. And that is one of the ways to back up this channel. Subscribe now. Tell your friend, and let your friend also tell another friends. Okay. Let's make this exact differential, this topic go viral. Okay. Let's make it go viral. Thank you for doing that. So this is where we are now. This is where we are now. We can use this one, the first one. We can use this one also. I mean, the f, the y, the f, the x. We can use either of the two to get the general solution. So let me use the first one here. Integrate both sides, and that will be f equal to Integral of my m is what? My m is what? 2xy. 2xy. Then don't forget this one. To go to this place. That will be what? Del x or the what? Del x or del x. Okay? So then plus arbitrary constant g of y. Okay? Then here we are doing partial integration. We're not doing full integration. So what you're going to do, you're going to integrate 2xy respect to x. Okay, we're going to spot x only. Okay, and integrate that, and that will be equal to, this is power 1 plus 1, that will be 2x squared over 2. The y will be kept as a constant. So this one and this one we constant, we cancel. So we have plus what? Plus g of y. That's our f. Okay. So that's what we have in that place. And I want to say also, please take your journal, take your pen, so that you can follow along with the speaker. It go beyond just looking. This is not entertainment. This is not dancing. So take your journal and begin to follow along with the speaker. Is very crucial. This is a serious business. Especially if this is your one of your course, this engineering course. I know you take it serious. This engineering course, and is a very very important topics. Okay. So take your journal, take your pen, okay? And as you are doing that, smash the subscribe button. Subscribe right now, okay? Let's make the algorithm to push this video to larger audience, okay? We can do it, okay? Don't stop there. Give the video this like section a thumbs up, okay? And begin to type your comment. Say something. Begin to type your comment. Which one are you using? Are you using the left, the lex, or the left, the y? Partially differentiates partially partially with respect to y. So, and that will give us del f del y. Okay, and the left, the y is here, is equal to n. Okay, equal to. We differentiate this with respect to y. You're going to have s squared. You keep your s squared constant. You differentiate your y, which is 1. And then plus what? Plus g prime of y. So our n is x squared minus 1 equal to what? S squared plus g prime of y. So this one and this one cancel. So we have g prime of y equal to minus 1. Okay. So in that case now, integrate both sides. To do that, we are going to have g as a function of y equal to what? Integral of minus 1 the what? The y. And when you integrate the y, it's going to give you y. And that will be what? Minus 1, minus y, plus 1, plus c, 1. So you now go back to the equation which I asterisk and substitute your what? G of y, which is equal to c. Your f is equal to c. That's the solution, equal to what? X squared plus g prime, g of y is what? Minus y plus c1. Okay, so you can combine this one and this one together, and that will be equal to what? This one minus y equal to what? Equal to c. Okay, so that's the general solution. So that's what we have for the second question. So that's what we have for second question. We have y e to power xy minus 1 over y dx, and then plus x e to power xy plus x over y squared dy equal to 0. So without wasting time, we correspond this one to the standard form, the x plus n, the functions of the equations, the functions of two variables x and y, the x, the y equal to 0. So my m, don't forget I said the attachment to your dx is your m. So that will be equal to y. We have this minus 1 over y. Okay, and then my n is this one. Okay, so we're going to do the partial differential of m respect to the other function, respect to y. So look at what we have there. Look at what we have there. Respect to y. This will be a product rule for y times e to power xy. I'm going to do the y first. That'll be 1, and then e what? Xy. Okay? Then minus, plus. Now keep your y constant. Keep your y constant. And differentiate your exponential function. That'll be this. And then the power, which is xy, do that respect to y. That'll be what? That'll be x. So we have xy exponential to power x, exponential to power xy. So that's all we have in that place. And then here, respect to y, if you do this one, I think that will give us plus 1 over y squared. Plus 1 over y squared. You have y, 1 over y, which is equal to y to power minus 1. And that will be equal to what? Minus 1, y to power minus 2. Okay, and there is minus there initially. So that will become plus. So let's get the n also. Let's get the n. So the n, respect to this function, respect to x, okay, it's also product rule. We do the x first, that's 1. We keep the e function constants, okay, then plus. Now keep your x constants, differentiate the e function, okay, and then derivative of the power respect to x is going to give you y. So we have that. Now differentiate x over y squared. That one is very simple. You only do the numerator, and that will plus what? 1 over what? 1 over y squared. And how do we do that? If an equation is exact, then there must be, there must be, there exists a function f. The functions of two variables, x and y, such that partial differential of f respect to x is equal to m. So integrate both sides. So f is equal to what? F is equal to integral of, my m is what? Let's check that. My m is y, e, that's all we have. Then minus 1 over y dx or dx, and then plus the arbitrary constant g of what? G of y. Integration. So the y is just a constant. Leave it there. Then now integrate your e function, and that will be what? Anytime you integrate e function, it's going to give you the function back. But we need to get the derivative of the power, derivative of x, y, respect to x. Okay? Respect to x, which will be what? Which will be y. And then use it to divide the given function. Okay? So when you do exponential, for example, now you have ddx of e to the power 3x. Okay? For instance, now, for example, it's going to give you back that same function. But you must divide by the derivative of the power. By the derivative of the power. So, over what? Over 3. And that's what I've done in this case. Plus g of y. Okay? So we have e to the power xy plus g of y. That's my f. Call this one equation star. Call it, give it that name. Is to want to find the g of y. And to get the g of y, we need to take the what? We need to differentiate that equation asterisk, differentiate that partially with what? Del f, del what? Del y, which is equal to n, okay, equal to, differentiate this one respect to y, that will be e to power xy respect to y. So that will be what times what? Times x. Okay? So when you are differentiating, you multiply by the derivative of the power. Derivative of this one respect to y is x. So times the e function plus s squared over y squared, okay, equal to this one plus g prime of y. So that's what we have in that place. So I told us from the intro that this something must cancel. So this one we cancel. So we now have these two left now. We're due respect to y. So I'm going to take this s squared outside the integration. Is a constant s squared outside. Then we are going to have 1 over y squared, which is a y squared, y to power minus 2, the what? The y. Okay? So let's integrate that. If you integrate y to power minus 2, so plus 1 over what? Over minus 1. So that will give us what? That will give us y to power minus 1, minus 1. So that's equal to x squared. Don't forget the minus that is here. So, and then y to power minus 1 to go down, or what? So, and then plus what? Plus c1. So that's what we have for g of y for that particular question. So please let me know what's your reaction. If there's any comments, put it down in the comment section. Put the what and put the g of y into that place. E to power xy. My g of y is what? Minus x squared over y plus what? Plus c1. And don't forget, this f also is what? Which is general solution, is equal to c, the capital C. So you can move this one to the other side. So constant, whether you add it or you subtract it, will still give you your c. So the final conclusion is what? E to power xy minus x squared over y equal to what? Equal to c. And that is the end of that solution. That's that on that solution. Okay, welcome. So the thing is about this is that you just need to keep practicing. The more you practice, the better you become. Okay, perfection comes through practice. So keep practicing, solve as many questions as possible. Okay, I will try to solve up to 5 questions before we go for this live section. Okay, and in this channel, there are bundles of questions, a lot of questions on exact differential. This is just an update. I'm going to put the link to those questions so that you can what? You can have enough questions to practice with. Okay, that's what we are known for. There's no topic we discuss that we don't back it up with lots of questions. Okay, so that's what we always do in this channel. So please subscribe. That is the business of the day. Okay, that is the business of the day. Subscribe so that the algorithm can push this video to larger audience. Okay, so what do we do? It's very simple. What we are going to do is very simple. Actually, when you have this kind of differential equation, it will always in this format. In the format of what? In this format of m, there must be a function of two variables and then the x plus n, okay, and the functions of two variables. That means the equation is of that variable x and y. It's not every time to be x and y. I'm going to give you another question that it will be x and y. Okay, but it must be a functions of two variables. So this will be dy. What this means is that the attachment to your dy is your n. The attachment to your dx is your what? Is your m. So m from the given question will be tan what? Tan y minus 2. Minus 2. So that will be the m. Welcome. You're welcome to the channel. Okay. Welcome. Okay. Begin to type your questions. So this is what we have for m. And we're going to differentiate this one partially. That will be the m, the what? Respect to the other function, the y. And when you differentiate tan y, that will give you sec square y. These two is just a constant, and that will be 0. The n in this case, this question is x sec square y plus 1 over y. So you're going to differentiate this one respect to x. Respect to x, you can see the y. So respect to the other function, respect to x, partially. So let's check that. This one involves two products. One is a function of y, one is a function of x. So the functions of y will be kept as a constant, and then we differentiate the x only. And differentiate x with respect to x, that's 1. So it's giving you sec square y. 1 over y, if you differentiate with respect to x, is going to be 0. So automatically, this is what? This is exact. This is exact. That's exact. Okay? That's exact. So that's what we have in that case. Then if it's exact, then the implication is that there is a function. There is a function f. This symbol means there is a function f such that in that case now f will be equal to my m is what? My m is integral of tan y minus what? Minus 2. The what? Del x plus g of y. Okay? And that will be equal to, if you do this one, tan y will be a constant. So you are having integral of tan y dx or del x. So that's what we're having in this case. And then minus 2 del x or the x. So, and then plus what? Plus g of y. So that's what we have in that case. Okay. So f will now become, we now have f. We're going to have f. Tan y is what? Tan y is a constant, so it's going to be x tan y. Tan y is a constant. You are only differentiating del x or dx. So that's the only one you are differentiating there. Tan y is a constant. And then minus what? Minus 2x. And then plus what? Plus g of y. So that's what we have in that case. Okay, call this one equation star. Call it equation star. Then differentiate this one partially. Differentiate partially with respect to y. So I'm going to have del f, del y, the left del y is equal to n. The left del y is equal to n. And we have the value for n. My n is what? Is this one. That's this. Plus 1 over y. That's my n. Then let's now differentiate this one respect to y. I've told us that on the intro that something we cancel out. This one and this one we cancel. Then we have g prime of x equal to what? Equal to 1 over y. Okay? Equal to 1 over y. equal to 1 over y, equal to 1 over y. So integrate both sides. If you integrate both sides, g of x is equal to what? Is equal to, if you integrate both sides, g of x, you're having 1 over y, the what? The x. So 1 over y is a constant. So it's going to be what? It's going to be, you keep that one outside, you're only integrating your del x or dx. So that's equal to what? X over y. Okay, as your what? As your g of x. So then go back to your f equation. Come back here. That's x times tan y minus 2x, and then plus what? X over y. Okay. I didn't add these are plus c1, plus c1. Okay, and your f is equal to what? Is equal to c. Your f is equal to c. Your f is equal to c. Your f is equal to c. So final conclusion, we have x tan y minus 2x plus 1 over plus x over y equal to what? Equal to this one minus this one. That's c. So that's your solution to the differential equation. Video across the social media platform. Share the link of this video across your social media platform. Okay, thank you for coming on board. If you're new, please subscribe straight away. Subscribe right now. Give the video a thumbs up, and then share. Let this video go viral. Okay, let it go viral so that the algorithm can push this video to larger audience. Okay, so this is what we have, the two questions. I'm going to take the first one. I'm going to solve that one so that we can also go to another question. The second one, I've already, I think today, I've made the short of this video. I'm going to upload that very soon. So if you cannot solve it, check my short video. You're going to find it there. Okay, but please, let's see how you do it, and put it in the comment section. I mean, the second one, put it in the comment section. This is m, the functions of two variable, sine x cos y minus x dy equal to 0. So put this one in the comment section. Let me know your answer for that. Okay, we've been told initially that the equation is exact. So we just need to state the condition for exactness. The condition for exact equation is this. That's step 1. That's the condition for exact equation. That's step 1. Then what we are going to do now, we're going to look at this. Correspond this to the general equation. If you correspond to the general equation, correspond this to the general equation, this implies n is equal to what? As a function of two variables, n is equal to what? Sec square y minus x over y. That's my n. And you're going to differentiate that n respect to the what? To x. So I'm going to do partial of n function respect to x. Okay. Here, this one, if you do this one, this is a constant. That's 0 there. Then this will be what? Minus what? Just do this one. That's 1 over y. The y is the constant. So we have minus 1 over y. And the next thing to do now is we've gotten this one now. So we now go back to that equation. We go back to that equation. I would also type the words of the question in the description for this question 4. So you've gotten partial differential of n with respect to x. So just go back there to that condition for exactness. Your del n, del x, we have the value as minus 1. Minus 1 over 1. Then integrate both sides. So m is equal to what? M is equal to integral of what? You can take the minus out. That's 1 over y del y or dy. Okay, plus since it's a function of y, the constant will be what? G of what? G of x. That's the arbitrary constants. That's the arbitrary constants. Okay. So final conclusion is to get the integral of 1 over y, which is equal to respect to that respect to y, which will be minus natural logarithm of y. Okay, plus what? Plus g of x. Solve it to show whether the equation is exact. If it's exact, we're told to solve it. We're told to solve it. So that's what we are told to do. We are told to solve it. So please begin to tell your friends, your friend. This course is very important. Okay, very important topics. This is exact differential. How to tackle, how to solve exact differential. How do we solve it? Okay, how do you know which one is m, which one is n? So these are the things we've been discussing for the past few minutes now. Okay, we solved question 1. We are in question 5 now. Okay, so how do we solve this equation? There's no magic. We are going to follow the guidance rules. We're going to follow the lay down rules. This is the x, this is the y, is equal to 0. Okay, that's the format for exact differential. You must have an expression, okay, the x, another expression, the y, and it must be equal to 0. Then you can now check if this exact or not. But before we can do that, we need to what? To decode what is n. We need to also decode what is what? What is n? That is a prerequisite. That's the first thing to do. So correspond this to the general equation. You want to know whether it's exact. Correspond to the general equation, which is this is general equation for exactness. This is general equation for exactness. Okay, correspond that to the general equation for exact differential. Okay, please don't just be watching. Begin to tell somebody also. Let him join us now. Okay, let him join because the class is going to an end. Okay, but I'll still try to look for more questions. I want the class to be long, and I have an expectation for this live section. Okay, if you're working alone, please tell your friends, tell your classmates. This question is very important, and I must tell you, I got this question on the past question from one of the country in the. I don't want to mention the country. So, and it's not even my country. So this is a past question. One of my students' questions. This is one of their past questions. So this is not a play. This is very important questions. Okay. So that is a past exam question. So if you are here, take your journal. Take your journal. You go beyond watching. Okay. This is not dancing. This is not entertainment. This is educative. Take your journal. Take your pen and begin to work along with me. Very important. Okay. And the more you do that, I want to tell you, you get certain percentage of assimilation. By just looking, the assimilation will be very low, even maybe possibly 0. But you begin to follow along with your journal, you get certain higher percentage of assimilation. Take your journal, take your pen, and follow. Let's do it together. So this is what we have now. This is what we have. My m, My m is this 2x plus can we make it this way? That's a 1 plus s squared y squared. Okay, I want to I want to make it of the same form. That'll be y times 1 plus x squared y squared to power minus 1 to be of the same form. So can we differentiate that respect to the other function, respect to y? So that will be what? Del partial differential respect to m, partial differential of m respect to y, and that will be equal to here. There's no y here. So that is a constant, that's 0. That one is gone. Coming back here. This one is going to involve chain rules. Okay, so I'm going to differentiate y. That will be 1. Keep this one constant. 1 plus s squared y squared to power minus 1. Keep it constant. Do this one and keep this one constant. Then the next stage is a product rule and at the same time a chain rule. Now keep this one constant. Now differentiate this one, 1 plus s squared y squared, the power minus 1, that's minus 2, and then times the derivative of the composite function, the derivative of the inner function, okay, respect to what? Respect to y. And that will be equal to what? Respect to y, that will be 2s squared y. I'm only doing the y squared, which is 2y times what? Times s squared. The derivative of 1 respect to y is 0. So that's that. Let's do the algebra for this case. Actually, we don't need to do the algebra because we want to check if the equation is exact, and that is the bone of contention. Okay, so let's get the second one. The second one, the end function. The end function. This is what we have here. There's no need to write it again. That's my end. Can we do the partial differential of that function respect to x? Respect to x. Respect to x. Respect to x. But I think let me write it first so that to avoid mistakes. So I'm having this one. I'm having x times 1 plus s squared y squared. 1 plus s squared y squared. And then that will be power what? Minus 1. Okay, for that one. And then minus 2y. So that's what I have. Let me now do the partial differential of n respect to x. This one is going to involve a product rule. It's going to involve a product rule, and at the same time, it's going to involve a chain rule. So I'm going to differentiate the x now. That's 1, and I'm going to keep this one constant. I'm going to keep this one constant. I'm going to keep this one constant. The power minus 1, that's minus 2. Then times the composite function, the inner function, respect to x. So respect to x is going to be what? It's going to be, I'm only differentiating the s squared. So that will be 2x y squared. This one, respect to x, is going to be 0. So I hope there's no mistakes. I'm going to check. I can see the mistakes. Let's check. Let's check. And coming. Oh. Apology for that. So once you differentiate your x, this one you keep it constant. That's the first case. That's a product rule. Okay, you differentiate this one, the x function, then you keep the other function constant, product rule. Then now plus you now keep the x which you have already differentiated in the first case. You now keep it constant, and then you now differentiate the second function. Okay, and that'll be what? That'll be equal to 1 plus x squared y squared, the power minus 1, that's minus 2, then times derivative of the composite function respect to x. That'll be what? Times what? times 2xy squared. Okay, so if you check it now, you don't need to do the arrangements. Check it now. Look at partial differential of n respect to y. Look at the first part is there. It's also the same thing here. This is 1 times 1 plus s squared y squared bracket close, power minus 1. The same thing is here. Check the second part here. This is x is here, x is here. That's 2x squared. This is also what? This is also 2x squared. This is y squared. This is 1 here. This is 1 here. Making y squared. So automatically, this is what? This is exact. Okay, this is what? We have shown that the equation is what? Is exact. So this is what? This is exact. This is exact. So welcome. The solution will be a little bit long due to the nature of the equation, the differential equation we have. Okay, welcome, 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 welcome. Welcome to the channel. You're welcome on board. You're welcome on board. If you are yet to subscribe, please do that right now. Exact. We're going to use any of these. Partial differential of f respect to x is equal to m. Okay, and this will be equal to integrate both sides. F will be equal to m is what? Let's play this one. So m is my m is 2x plus y over 1 plus s squared y squared. That's my m. Integrate this one. That'll be what? The x. Then plus what? Plus g of what? G of y. Okay. So let's see what we can do to this one. Now let's see what we can do to this one. G of y. So this will be equal to, if you integrate this one, 2x, that'll be what? 2x squared over 2, then plus, plus. Can we also integrate this one? We can bring the y outside. That is 1 over what? 1 over 1 plus x squared y squared. Okay? Square y squared. So the x plus g of y outside, taking the y outside, I can write this one as 1 plus s squared y squared to power what? To power minus 1 dx. Okay? And then g of y. So that's what we have there. Okay? So we can write this one outside. Let's do it outside. This is y over 1 plus s squared y squared dx. So what we're going to do, let's make a u. Let's have a u be equal to x, y. So the u respect to x, because the functions of x, the u respect to x, that's y. That's y. So the u is equal to what? The u is equal to y dx. That's my du. The u is equal to y dx. So we can go back to that equation, make substitution for what we have done so far, and this will be equal to what? That will be integral y over 1 plus what? 1 plus, this place will be u squared, this is u squared, times, we can make the x as a subject. Let's make the x here as a subject. So the x is equal to what? The x is equal to the u over y. So this will be equal to what? The u over what? Over y. So this one cancel. So it makes the work easy. It's still the same thing I've done. It's still the same thing I've done before. So, and this will give us what? So this will give us This will give us the arctan u. That'll give us arctan u. So that's what we have there. That's arctan u for this integral. That's arctan u for that integral. Please copy that. That's arctan u. Arctan u. And then I've done that. I've done that. This will be arctan. Your u is what? Your u is xy. Come back here and substitute your u there. Y now. Let's find the g of y. In this case, let's find the g of y. So in that case now, differentiate this one partially respect to y. Respect to y. So this will be equal to what? Partial differential of f respect to y. Okay, and that's equal to n. That's n, and we have the value of n. Our n is what? Let's check that. Our n is our n is our n is x over our n is x over 1 plus s squared y squared minus 2y. That's the n equal to equal to. So that's the n. So we're going to differentiate s squared respect to y. And that'll be constant at 0. Differentiate what? Arctan xy. Arctan xy. Differentiate that. No. Arctan xy. If you differentiate arctan xy, it's just as if you are going back to the previous. So that will be equal to the derivative of arctan is what? Is 1 over 1 plus the square of this one, as s squared y squared, and then times is it times now? Times the derivative of the inner function with respect to y. So times what? Times x. Okay, and then plus what? Plus g prime of y. So actually this one also. So by so doing, this one and this one we cancel. We have g prime of y is equal to what? Is equal to minus 2y. So integrate both sides. If you integrate both sides, you're going to have g of y is equal to minus 2 2 over 2. So this one and this one cancel. We have a minus 2y squared. So that's what we have in that case. So that's what we have in that case. Minus y squared. So on the final notes, we're going to and don't forget the c1 plus c1 plus c1 plus c1. So we're going to have f. Come back here and substitute your what? Your g of y. Come back and substitute your g of y. So we have x squared plus arctan 1 xy, and then minus what? Minus y squared plus c1. And this f is also equal to what? It's equal to c, capital C. So the final conclusion, x squared plus arctan xy minus y squared equal to what? Equal to c. And that's the final conclusion to that question.